Hi, good morning or afternoon, wherever you may be joining us from, and maybe dinner for all you late watchers after this has been posted and recorded. Really excited to be bringing you this LinkedIn Live presentation on how we can harness the power of collaboration in helping everyone design their CEA facilities. This is a fantastic industry, and we are out here to kind of make everyone's dreams come true. This is some really powerful stuff, and we really hope that we bring some really insightful information for everyone who be tuning in to us today. And let's kick it off by introducing our cast for today's show. We have Chris Cervani, who's a CEA advisor for Bridge City Global, based here in Pittsburgh, Pennsylvania, where Tom and I are located. And we have Erica Summers, who's a mechanical engineer and another CEA advisor currently in Las Vegas. Good morning, Erica.
Mhm.
We have Tom Berzuz, who is a senior electrical engineer in the McKim & Creed office, who has worked with me on lots of different CEA facilities, and myself, our moderator slash host. I'm a mechanical engineer by training, and very excited to be working within this, really excellent industry. It's just so much fun to even be able to talk about this. Let's talk about what we're here to do today. Tom and I are both engineers working for McKim & Creed. We're an engineering consulting firm that is common across all around America. And, we want to be talking with Chris and Erica today about why it's important and sometimes necessary to actually be engaging with engineering consultants when working on your facility, early and with lots of communication. Let's kick it off. Chris, what are some of your thoughts on this?
Yeah, I mean, thanks, Ryan. It's interesting. Like I spend a lot of time talking to people who either operating CEA facilities. I worked in a CEA facility for the last 4 years here in Pittsburgh, and then have toured a lot since starting this consulting business, involved in the industry for 25 years. So these projects, from my perspective, come from like two different perspectives. One where there's like the grower or a farmer who wants to build this kind of state-of-the-art high-tech farm, and they're trying to figure out how to do it, and they want to just take what they did horizontally and stack it in a vertical situation, or they want to figure out how do they bring it indoor and bring all this automation. And the other side I see as these tech developers that are engineers that want to build a farm, and but they don't necessarily know how to grow the plants. They know how to design for automation and moving things around, but they don't necessarily know how to grow the crops. And both situations really require this handshake, and it's not a one-time event. There's this constant conversation where it's a back and forth. Well, this is what I need for my crop, but what's the implication of that? That's where the engineer consultant comes in on the other side and really can help understand the cost, the impact, the challenges with any given parameter that we might set. I need the temperature to be this. Well, this is what that means in equipment. So just to bring that back around, the importance of collaboration with grower consultants and engineering consultants is key, and hopefully you'll learn that as we go along through this conversation today.
Yeah, absolutely. One of the strong benefits of talking with engineers is kind of that deeper understanding, and of a lot of different project variability and history that can always be applied to your project. That there are lots of lessons learned that the engineering professionals have dealt with that know how to really apply them. Eric, I know that's a lot of how you've gotten really a lot of knowledge in this kind of realm. Do you want to talk about that?
Yeah, so the thing about like indoor farming versus traditional farming is a tried and true method that has a lot of deep knowledge and deep expertise. In this industry, it's still very new, and I think that we get lost in the fact that this is such a new and emerging industry. And in order to successfully deploy a vertical farm, a CEA facility, anything like that, you need to have multiple different people with multiple different skill sets. We need a grower, you need an engineering team, and you need a finance team that all work very, very closely together, because one of the things whenever I'm talking with clients about, well, what do I do here? What do I do there? It always depends. The grower needs to understand what growing environments they need, but they also need to have a somewhat understanding and can articulate that to the engineering team of, here is what I want, here's what I can settle for. Where can we meet in the middle so that we're not over engineering a system that is perfect for my needs, but the finance person is saying that we're blowing our capex way too high, or it's way too much. One of the examples that I love is is this industry wants berries, strawberries. I hear that all the time. Strawberries are a cooler weather crop. So I've talked with facilities that said, well, I want the flexibility to be able to do strawberries. That's great. Why do you want your entire facility to be able to go from 53 degrees to 82 degrees so that you have variability? And the grower sat there and looked at me and was like, what's the deal? And I said, look, being able to go from 53 degrees to 82 degrees in an entire facility versus building yourself one small room where you can do strawberries, which is your intended production, and then changing the environment in the rest of the facility so that you're not 3 times your cost of your system. Like, those are things that having advisors, having growers, having engineers, having finance people that all can put their, my favorite thing to say is egos kill farms, that can put their egos to the side, come together as a collaborative team and put together this puzzle in a respectful way. That is how these projects will get implemented properly versus a facility that can, the entire facility can grow strawberries. That was never the intent. And you've got 3 times the cost for the mechanical equipment for no reason. So,
Yeah. Yeah, and definitely, getting that engagement going early on is, really key in order to really build a successful project and really structure things early on, have a greater foresight of where the project's going to be going from that first proposal. Tom, what are some of the keys that, as the engineer being engaged in the project early, why, what are some of the things that you see and have experienced that make it important for us to be involved?
Well, from an electrical engineering standpoint, one of the key ideas is to gather information on what the loads are going to be for the facility, and we'll probably get a little bit further in the discussion as far as what may go into a particular facility. But the key thing from the electrical engineering standpoint is to come up with a load tabulation that we can present to the electrical utility for serving the area of the project. That's key to starting the project and finding out if the utility actually does have the capacity on their system to deliver power to the facility. But also, many of the utilities, they do not have a complete understanding of what goes into these facilities. And when you present them with loads, the cultivation lighting loads, and also the HVAC loads that are the highest loads that we would be seeing in a facility like this, they just look at that and just can't imagine. But there's the possibility that they may need to increase their infrastructure to bring power into the facility, whether it's a brownfield facility that's in the middle of a urban area, or it could be out in the middle of a field in Iowa. Uh, those are some of the challenges that we have to face, and so we try to gather the information up front so that we can at least give the utility some idea of what they can expect and what their infrastructure may need to what we may need to do there. Uh, it may mean that either the utility can provide the transformation for the facility, or It may mean that we do a primary service where the end user would then have to pay for installing the transformers that would and the electrical gear that would be required for servicing the facility. So those are some of the things that we have to consider upfront and in the discussion with and collaborating with the owner and also their team as far as the cultivation lighting, what they're proposing to use there, and then also with the other engineering disciplines on HVAC and plumbing.
Yeah, Tom. So one of the there's a lot there that we can break down, but one of the key takeaways there is you need to really be kind of purposeful when you're engaging your engineers. When you're bringing on your engineering team, you need to make sure that uh, they actually have the understanding as well. There's Tom was mentioning actually understanding the load tabulations for the lighting and applying the right diversities to them, understanding how to estimate those HVAC loads and be able to communicate them properly to those local utilities to make sure they understand what's really happening in this facility. And engaging the right engineers, they should have this kind of information, this kind of backbone, in order to really make sure the communication's happening. You can have some negative happens, like there's poor reactions to things when you engage the wrong engineers who might not fully understand how the grow cycles work, how to properly size your HVAC equipment, all the components you really need. I know, Chris, you had a story about that.
Yeah, it was. There's 2 points I want to make with that. One was, as Tom was talking about calculating these loads, and then back in the day, a few years ago, there was all these cannabis facilities you'd hear about that they would be all ready to go, and they're just waiting for power to get turned back on or to turn on because they built the whole thing without realizing the grid couldn't support it yet. And I think one of those really key lessons is that if you are at the end of the grid or you have to get a special transformer installed to be able to power your facility, order 2 to make sure you have a backup transformer if anything were to go on with that. So now that said, the other important thing is that understanding those needs of the building inside, heat loads and things like that. I know of a farm that didn't install supplemental heat. They were relying on the lights in the racking to heat the facility, and they do that, right? The lights, even though LEDs are very efficient, there's a lot of them especially in a vertical farm, and they produce heat, and that does heat the facility. But when those lights are off, there isn't any more heat, and so then you get in this cycle where, especially when the facility is processing humidity at the expense of temperature in the room, it'll just keep getting colder and colder and colder in the grow room, and it needs to be warmed back up. So then what happens is CapEx projects, it's far more expensive to go back in and install an upgraded HVAC or the proper HVAC after the facility's already built, much more expensive than building it right the first time.
Yeah. Eric, how do you really make sure that stuff is captured? How are you making sure your engineers are properly doing their load estimates and equipment selections proper before they even show up on site?
We have a joke that when I'm qualifying a group of engineers, I will ask them, hey, what's your experience with pools? And if they go, oh, I hate pools, then I know that if they don't have any CEA experience and they hate pools, they might not be the best fit for the project. Reason being, then when they turn around and say, but we have data center experience. Data center experience is something that it's a very good experience in the mechanical engineering world, but it is a condition where you are driving down the humidity for equipment, not for plants. Pools are much more applicable to a plant environment because you have that high humidity, you have the higher temperature, you have that just more difficult environment that you need to control. Going back to kind of what Chris was saying, one of the things, flat out, any units that you have in your space need to have reheat capacity. If you do not have reheat capacity, you are not going to be able to contain that or be able to control your humidity and temperature set points to the places that you need. Now, I know I'm going to get some slack for that because desiccant applications are something that are there. Yes, is some specialized equipment that's coming into this space that I'm very excited about. But for right now, unless you have somebody that is extremely knowledgeable in desiccant and can ensure that you are correctly sized and it's perfect application, you're going to be using normal refrigerant based units, and the normal refrigerant based units need to have reheat. Now, for the people that don't understand what this means, I'll explain it really quickly. In the way a refrigerant system works, you've got a loop, and the refrigerant goes around this loop, and it's either compressed or it's expanding. When it's compressed, it's heating. When it's expanding, it's cooling. So you've got a compressor, a condenser, an expansion valve, and a cooling coil. This isn't so much necessary as understanding that the cooling coil is where that air from the grow space is coming over, and it's condensate is developing and it's falling out. And then you've got cooler air coming through. So the reason why you need to have a reheat is if you are just trying to dehumidify the space, you are constantly running that air over these cooling coils and you've got this cold air. Now, there's two things about that. The colder the air gets, the less it will dehumidify. And you've got really cold air just going into the space. So you're trying to dehumidify out this air. This air is cold. Your grow room is off because your lights just turned off. You are literally just dumping cold air trying to handle this dehumidification. So you always have to have some sort of reheat capacity so that you can control the two and you're not just freezing out your room. And any mechanical contractor that looks at your unit is going to say, why do you have a reheat? That's not something that's normal in HVAC units. And they're going to say, hey, let's value engineer that out. It's more expensive in the unit. We don't think you'll really need to use it. Your lights will heat up your grow room. You don't have a problem. And it is right there that it is so critical that you have engineers with experience that can articulate why this things like reheat is important and protect you from those value engineering cost savings, because they're very attractive. I've seen it happen. It's some multiple magnitudes of cost, and you're like, oh yeah, they said it's fine. Why would I spend this more money? But if you don't have that, you don't have room conditions and you're going to have issues. So engineers understand what it is that we are doing, why we're doing it, and that can defend you during the construction process is critical.
Yep. Yeah. So there's a lot of great points there, and to tie what everyone's saying together, when you are in the, you've hired a engineering consultant onto your team, and now you're at the BOD phase, the basis of design, where we are now looking at the footprint of the building, and we are starting to talk with the growers to get some of the inputs. As the mechanical engineers, we are starting to size our equipment and get quantities, get lighting loads, get electrical loads. And these are all really important things because, when it comes to the reheat, there are going to be multiple applications. There's going to be times during a grow cycle where, let's say, the room needs to be pretty dry and still warm, but you're putting a lot of water into that space. All of that water needs to get dehumidified. So to build off of what Erica's talking about, if you're trying to dehumidify this air more and more and more, but you need that room to be warm, you are not actually able to keep that warm set point unless you're adding heat. Now, when engaging with an engineer early, they're going to understand how that refrigeration cycle works. You can get some free reheat using a hot gas reheat loop, within your system itself. There are going to be conditions where you might not actually get that much heat back due to the actual incoming air and the amount of cooling that's needed in order to provide the dehumidification. These are, these are things that the mechanical engineer is going to be handling. So when the mechanical engineer sees that you don't actually have that much reheat, that calls for simultaneous heating within the unit itself. And that's going to be an electric heat typically. You're not going to want to put gas heat for this part of the application. So if we're designing a facility that has 5 different grow conditions, and each of those units are going to be 40-ton units, that's pushing 8,000, 10,000 CFM, just a lot of air coming through. You're going to need a large reheat coil in order to get that heat up. And all of that heat goes straight to that electrical load. And that's what Tom needs to know in order to provide that load tabulation to the utility company. Because if those units are running at max capacity while also having these reheat coils on, you don't know if, unless you have that insurance of your load tabulation, you could be completely shutting your building off of power, because that is a lot of energy that you're going to be expending. And
hey, Ryan, could I just jump in? I want to say something, because you just called out something that's really important that I didn't understand as a grower until trying to drive one of these farms. Because you think about the conditions that you're trying to set for growing these crops, and I mean, especially in a pesticide-free facility, we are concerned about humidity. That it's going to, if you have too much humidity, then it's going to grow all this mold, and I'm going to have this issue where it's going to be disease. It's going to impact the quality. We're going to have all these problems. But I think it's really important to call out what you just said. And if I may, I'll paraphrase. It's that we are irrigating these crops. We know that we need lights and we need water to grow a crop. And if you want a high temperature in your grow room, low humidity, while pumping that in there, that is hard. It's expensive. That is a mechanically a real challenge to try to provide consistently, because you got all this water and now you're trying to dry it. And then when that dry air comes back, to the point of Erica and everything we've been talking about, that's going to be cold air when it comes back, or cool air when it comes back. So then it has to be warmed up, and then it has to be cooled down and warmed back up. And so processing the air is what gets really expensive. It gets in this loop, and then you're using all this energy. So I think when you're thinking about the requirements as growers, if there's any growers on the call, you're thinking about what you want to do, there's some magic in finding that balance between what humidity control you actually need and what temperature you need to drive your crops, and working with your engineer partner to understand the cost implications of whatever spec you want to set around those things. It's really critical, because of this challenge indoors of hot, dry air. Is it hard to get?
Yep.
Again, if I can jump in right there, what Chris is saying is absolutely perfect as to why engineers and growers need to have these conversations, because we know what the equipment can handle. Growers know what the plants can handle. If we can come together and figure out where there are concessions, talk with the finance person, and just I've seen a lot where people will be like, well, we don't really know what we want to grow. And they throw out, kind of like I said with the strawberries, this wide range. And I've had to sit down and really go through and explain, giving us a wide range is detrimental to your capex of your facility, because yes, high temperature, high humidity, that is the most difficult situation. And if you're intending on growing something like a leafy green or a lettuce, if you're doing microgreens, then we'll figure it out. Make sure that it works out. But if you're doing something like a salanova or something like that, do you need to have that higher temperature, higher humidity? It's going to be a little bit lower. Where can concessions be made? Where can the team come together? And this is why it's really important for the team to be assembled in the beginning, because you're going to go through and you're going to say, okay, let's try this. Oh, nope, that's way too high of a capex. Well, let's look at this business model. Okay, we can do the environment conditions, our energy cost isn't too crazy, and we're growing the crops that we need in that market. But if you do not have those 3 pillars working together, one can easily topple the other, and you can get into a tough situation.
Yeah, that's a really good segue into talking about when you're when you're in this like early development phase, when you've put together your engineering team, your architects, and your finance and the growers, and you put everyone together and start talking, a common topic is flexibility, wanting to grow a number of different crops, and have the capacity in order of, one crop's not doing well, that you still have another one to fall back on, or maybe you want the whole facility to do something. These are early discussions that you need to be having early, because if you have a 160,000 square foot facility that you want to go into, you might not even want to fully build out that project immediately. You might only want to have your one crop growing right away that that you can immediately start selling because there's a market for it, or you've perfected it, or however you're treating that crop. But there are lots of benefits to making sure you have that whole team on early, and especially with that flexibility, and that's construction phasing. Construction phasing can be your ally when you might not necessarily know what you fully want to put into the project. Tom, I don't know if you want to talk a bit electrically why it's important to understand that phasing early from your background as the electrical engineer, why that's crucial in the design process.
Yeah, that's one thing that with the utility companies, they want to know what your loads are going to be up front, and so the planning that goes into this and the phasing, as you mentioned, those are things that we need to evaluate when we're going to the utility and asking for the service and issuing a request for service from them, so that we can maybe put in a transformer now that's going to serve part of the facility. But then if the facility is going to expand, either doubling the capacity or whatever, we would be able to put the infrastructure in place, and that's usually an upfront cost. And those are things that you need to consider upfront, because once you dig the ground or bring a line in, you basically need to put that in up front, so that further on down the road, if you're doing phase two, you're not going to have the ability to go through and disrupt what's happening in the existing facility. And so you want to plan that ahead of time and at least have the facilities in place, so that it's an easy offload, so to speak, of equipment that you can bring in and then add that capacity in the future.
Yeah, there's important diversity with that, and even more so with with how you actually are loading in your equipment. There's important things to highlight early on. Let's say you have that large capital in the beginning that you might want to pay the engineer to design the full facility. If you do that, you can get kind of a full scope of what you want everything to be. But you're going to have some VE changes. You're going to have some cut costs later down the line when you kind of get that final price to see what it all looks like. But why when we're talking about flexibility and phasing, there's certain aspects that you want to actually be going to someone like Chris or Erica to actually talk about the growing part of it. Figuring out what you want early, so that you can talk to the engineers. Chris, what are some of the things that you want to be considering before going to the engineers, so that we can work on that phasing process?
Yeah, I mean, there's so many things that kind of come to mind, and I think there's a couple examples. I mean, there's some of these things that you might not think about. So if you think about like the flexibility of what you want to grow and why that could be important, because if you're growing lettuce, like whatever your growing unit is, your thing, how you bring it out to harvest, it can have anywhere from, let's say, 1 unit to 36 or more heads of lettuce on a particular unit. You're going to convey that around your farm somehow, right? And so like, what's the weight of that you're going to be moving around? That could be completely different if I was growing something, a large stature plant that I need to move around the facility, and now its weights are completely different. And so like, I know that goes into some of the mechanical stuff, but just what you're growing can impact every other decision that's in the farm. Makes such a big difference. Another really flexible thing is like, when I think about the growing of the planting, and the substrate that you're going to plant into, right? And so what do I mean by that? The medium, what are you going to plant in? Is it dirt? Is it rock wool? Is it something else that they're going to plant in and grow in? And if that supply is not consistent, is all the plumbing and equipment set up to be able to handle all of that input that's in the facility? So what does it do? Like if you use a potting mix substrate, there's a good chance you're going to end up with perlite floating around in your system. And every grower knows this because they've seen perlite get caught in the filters and in the plumbing and all these things. But if you're a plumber that isn't familiar with the inputs in horticulture, that can be some of the challenges that you have, is that you've got floating particles that stick in a sump, for example, and then they have to get cleaned out. And so I think about those implications of some of the flexibility that growers know that they want, and how you can anticipate that an engineer might need to know that, right? And so I really need to go through the whole bill of materials in the growing process and talk with your engineering consultant to understand the impact on the design of the facility. If there's anything else that this requirement, I want to grow the crops in this way, I want to use potting mix substrate, and I want to grow in these trays, how does that impact the design of the facility? It probably has big implications. If I'm going to grow media, for example, where am I going to put it? Is there a place nearby that's going to be able to do it? I'm going to convey those inside. Those are some of the things that I think about from a grower perspective.
Yeah, especially. Yeah. And Eric, mechanically, kind of what are some of the impacts of mechanic and plumbing? What are some of the impacts of kind of thinking about those kinds of avenues?
Every time you tweak something, there is always a change somewhere else. One of the things that I thought was kind of funny in the cannabis industry that you saw is everybody's switched from the traditional lights to LEDs. And then all of a sudden, their rooms were completely out of whack. The reason being is the old lights put in a lot of heat. The new LED lights had less heat, but they were more efficient in the spectrum, so the plants were actually uptaking more and putting more humidity into the space. And in the CEA facilities, those kind of things happen too. Going from a lettuce to a basil, that's different feeding rates, that's different plant counts. There's so many things that change that you need to make sure, have that conversation and make sure that you're tuning your HVAC system to be able to meet those changes. One of the things that we don't talk about enough in this industry that is super important is HVAC, or just building controls in general. You're from not only a change standpoint to a seasonality standpoint, you have to have a good control system. If your HVAC units are just run off of a thermometer that's sitting on the wall 10 feet away from the grow area, you're in trouble. You need to have units that are with a control system that you can look at trending data. You can change inputs, you can change air mixes, you can change temperatures, you can make sure that you are tuning your room and that you are consistently checking on tuning your room as the grower changes things, as seasons change. Seasons changing, we have this idea that it's inside, outside doesn't affect us. No, outside always affects what's going on inside, whether it's how the equipment is running. If it's super hot outside or if it's super cold, you're going to have that cold infiltration into the building because of not enough insulation or things like that. Just be aware that it's super important to plan as much as possible in the beginning, but also know that these are living things and there is going to be changes all the time. So it's not getting into this mindset that, if we plan everything perfect up front, we'll never have any problems. We're planning up front so that we know where our redundancies are, where we can fix things, how we can adapt to things, and constantly keep monitoring this as a living facility.
Yep. Yeah, and there's definitely a big aspect right there that you alluded to, and that even though McKim & Creed, our office here is based out of Pittsburgh, that doesn't necessarily mean that we can't make our designs in Minnesota or Florida or California or Canada. As long as we are able to interpret those local codes and climate conditions, we can always design to the facility that you're looking for. That's a huge aspect and positive of engaging your engineering consultants. If you want to build your project in New Jersey, there's lots of different local codes that we need to abide by. That if you go to a local design build firm, they might not have that experience. It is our duty as engineers to make sure that we are abiding by local and municipality code to make sure your building will actually pass inspection and be able to stay there for a while. You don't want to build your building and then all of a sudden, the next set of codes come out and the proper infrastructure wasn't put in to meet code anymore. Now your building fails inspection, and now what? Now you have to pay for all this stuff to come back in. So there's definitely a lot of benefits to understanding that, even from the mechanical side, making sure that our equipment is able to perform in those climate conditions when we have our compressors sitting out or condensers sitting outside, and if it's 98 degrees and it's very humid, we want to make sure that we can still meet that cooling requirement. Same thing with outdoor rated equipment, generators. We want to make sure those generators are able to sit outside. We're designing in Florida. We want to make sure that we're meeting wind code, making sure our building doesn't fly away during a hurricane. That's definitely something that you need to be aware of, especially when you're doing these buildings. Early on in the design phase, and within the industry itself, CEA is very big proponent of energy efficiency and how we're trying to be a very holistic, growing solution. One of the topics that's often talked about is renewable energy and how that can be applied to the building itself in order to help offset some of those costs. Those are important things to talk about, but those are important things to understand early on, and that makes sure your real estate actually can do it. When we talk about renewable energy analysis, that's something that a number of engineering or specific consulting firms offer. That's something you would want to do early on, because there's only so much square footage on your plot of land, and there's only so much weight your roof can hold. Those are big aspects of
Yeah, particularly if you're going to add solar.
Right? Yeah, with your solar panels, there's only so much you can really do with that energy. And those are, if it's something you're interested in, you got to pay for it early on to get that analysis done. Because when Tom goes and does his load tabulation, he sees that it's a 2 megawatt building in operation. Are you generating that much power with your solar panels? And is it worth putting into that investment to put them in, only to find out you're generating a third of that, maybe, probably less? That's something that's really important to figure out in the design phase.
And we do have engineers that specialize in that aspect of it, that can also work with the general electrical engineer that's working on the project to provide that information that's needed and do the evaluation as to whether it's feasible to add that to the project, and then we can easily integrate it to the electrical system. And I think that's important to have that information up front, and to have the collaboration with the owner so that they understand what they would be getting for that. One of the things I did want to mention, you mentioned about codes a little bit earlier, and one of the things that we found in many facilities, if they're putting up IMP walls, the code requires that first responders, the radio coverage for first responders in a facility, that's something that is often overlooked, but it is required by the code. And when you put up the IMP walls, it's important that you do a study for the frequencies of the first responders in the area, the local area, so that you have an understanding that in most cases, the signal is going to fail in those locations. And so you have to add a BDA system, a bidirectional amplification system for those signals. And that's just a small piece of it. There's other code items that we need to follow as we evaluate a building, and so that's important to have that understanding and to implement it early on.
Yeah, I mean, I just last week was doing a site visit on a project that we designed that has those IMP walls, and within 5 feet of walking into the building, my cell phone was saying SOS.
Yeah.
So it's no joke. Like some of those buildings, when you're working with an architect and you are designing with these insulated paneled walls, to absolutely get perfect climate control in your growing environments, as well as make sure you have as minimal infiltration as possible to remove contaminants into the building. If you have pressurization issues, it's a big deal. It can have some effects that you didn't expect at first.
Right.
Another one to always be mindful of is sprinkler heads. You have to have a clearance from sprinkler heads. And if the fire marshal comes in and inspects your building and you don't meet that clearance, that is a very difficult day, because they will make you change it. And if you're already through the construction phase, that is a very painful change.
Right. Yeah, and just similarly, when you're talking to your consultants, you want to make it, clear and known that, that you are working with a product that is meant for consumption, and things like food safety is of utmost concern, because if your building doesn't meet food safety codes, then they can't even sell anything anyway. So, that is something to be very clear and upfront about. Make sure that they are studying and researching and applying those codes to your facility. Now, some of that involves is an architectural process as well, not necessarily relies only on the engineer, but that is once again a major collaboration topic that needs to be discussed while you're going through your design phase.
Yeah, I think Ryan, I just want to jump on that, because you're talking about food safety, and then the other one is maintenance of cleaning of equipment and maintenance of equipment and things, as well as we think about trying to pack these things into tight, efficient places. That's again a very important collaborative conversation. Your food safety expert, your grower, like what does it look like to clean out a sump, for example, and what that might look like. There's impacts to the facility design on all of these things, because it might be one thing to tuck it neatly under a growing rack, but if you ever have to get in there, how are you going to do it when plants are in the way? It's like these are some of these mechanics that are really important to talk through in this collaborative way to figure out the impact of, designing for efficiency. Everything's compact, but then how do you do it? Food safety, again, really important point, that like maybe you design, there might be a requirement for a specific temperature from food safety that the grower isn't thinking about necessarily, that food safety would bring in, or a special storage requirement that's needed. And all that has to be integrated into the design as well.
Yep.
Yeah, and that's not just a job for the engineers and the growers. That's also going to be predicated based on the clientele that you're selling to. Because if you're selling to grocery stores, if you're selling to restaurants, they are going to have different requirements. And I do know that if you're selling into any of like the mass production for one of these large grocery chains, their food safety standards are very stringent, and those are things that you have to be planning for in your facility in the get-go, like drains and a lot of things. So I know that it's kind of discouraging, because it sounds like there's a lot in this, but there are people in this industry. There's never going to be one person that knows it all, and anybody that says that they know it all is probably someone that you need to stay away from. But if you put together good teams of people, we know all of this experience because we've seen these failures, and because we are adaptable and seeing failures and coming up with solutions. So putting together a team of people, as I said before, where egos are left at the door, everybody is bringing the knowledge that they have and ready to overcome challenges as they go forward, is so important.
Yeah. So, we through this discussion now, we kind of talked about why, the whole topic has been why it's important to engage engineering consultants early. And then just now we've been primarily talking about the basis of design phase, kind of coming up with your early planning. But when your project moves into your schematic design phase, that means your architect's engaged, you have a floor plan, you have engineers have equipment that kind of worked on and selected. Now you're talking about facility planning, making sure and kind of tying into what Chris was just talking about, equipment accessibility and life safety paths, and meeting building clearance requirements. We This is a really important phase to nail down early on, because if you are going into an existing building that may only be the roof may only be able to hold the load for snow, you need to have a structural engineer go out there and kind of do those analysis. Because if you expect that you can put all your HVAC equipment on the roof, then and you only buy a certain size plot of land, well, you're kind of out of luck now. What are you going to do? You're going to put in the steel to build a mezzanine. That's a lot of money you weren't expecting. You find out you can only actually grow in a smaller square footage than you expected. That's something you probably should have, like, this isn't a really major item, because now let's say you do have that square footage available outside the facility and you're putting your equipment out on grade on the ground. Well, now you have to engage a civil engineer. I mean, the civil should be engaged anyway, but you need to make sure that this stuff is coordinated early on with your civil engineer and your contractors to make sure that equipment's not going into any wetland or violating any evac routes with your architect. This is stuff that you don't want to catch after it's installed, because that will absolutely blow up the timeline of your project.
You also have to be concerned with setbacks from property lines and that sort of thing, and any other ordinances that may be local for a facility. And then also, since I've been talking mostly about utilities, the utilities also have to be able to get back to the location of the transformers, and so there's special requirements for that as far as the roads to get back to it, and so those are key factors that the civil engineer can help out in that respect.
Yeah.
If there's, for myself, pitched roofs, wooden trusses, both of those, please, those are not good for these facilities. Can you do it? Yes. Is it worth the cost? Absolutely not. Pitched roofs, you can't put equipment up there. Wooden trusses, you don't have the structural support to put heavy equipment up there.
Yeah.
Please don't do it.
And another aspect with all of this is something that you really need to be paying attention to with construction deadlines and with your financial team is equipment lead times, steel lead times, just material construction lead times anyway. While our supply chain is still trying to catch up to everything, things are starting to balance out a little bit. But now our norms for some of these equipment arrival times are just weeks later than what they used to be, and there's a lot of adaptability that needs to happen even through the construction phase. When we are figuring out mechanical equipment, panels, transformers, generators that need to be there, as the engineering consultants, we are always designing and talking with different contractors and getting submittals. The submittal is what gets sent to us to actually confirm that this piece of equipment is viable for what we've designed it to and what will be being purchased by the contractor going on site. If the contractor comes back and says, hey, this special air handler that we owner likes, the custom designed, the lead time is 80 weeks. Everyone wants this piece of equipment. Do you want to wait a year and a half for this piece of equipment? What are some other, here's another piece of equipment available. And it is our designs. We own that ownership of the how these systems work, so we can actually properly select what needs to be put onto the site, make sure everything's coordinated properly. That is our expertise as an engineering consultant. Now, with 10 minutes left, if you have any questions, you can throw them into the chat, please. And we can get to anything. And as they're coming up, we can answer them anything immediately. All right, from Parker. Parker Golden, how important is it to allow for expansion in the future? Yeah, so when you're looking at a facility, when you're thinking about future expansion, there's a couple different ways you can think about it. You can think about it as a completely separate entity that you're going to need to be putting on new utility access and new engagement for your growing new equipment, everything. You can also think about it early on, and that's kind of what we were talking about earlier with the phasing of your project. You can straight up come in and buy a 200,000 square foot facility, but only do your first design for the first half, the first 100,000. That is a completely reasonable thing to do, and that's something that you want to be talking about with your finance guy. I don't know if Chris, you have any comments on that.
Well, I do. I mean, there's a couple of things that when I think about that too, like there's some the size of the facility, particularly the growing and processing area. Like I think it is so important. The smartest facilities I've seen are ones that allow expansion to do exactly what you're describing, Ryan, where you can turn on a portion of it and then you can add on to that incrementally over time. And then that could be different for each facility, but that you allow the ability to expand. So like you said, you buy a 200,000 square foot footprint, but then you're only going to occupy 25% at first and then expand over. But even a 50,000 square foot facility is large if you're trying to get started on this. Logistically, it is a challenge to do that. But keep in mind, when you're farming the farm, you don't plant all at once. It takes shifts and time to build up the capacity, and you don't harvest it all at once either. You do that in shifts, and it takes time to do that. And so that ramp is going to take time no matter what. Even if your farm was turnkey and ready to go and you turn it all on, it's going to take you time to ramp up the capacity of that facility. And as you turn it on, it allows you ability to commission over time. And I think that's really important. So the ability to separate out these zones to allow you to turn on one smaller portion at first, and then add another one, and then add another one, and add another one. And particularly if it depends if you're designing your own equipment or you're working with a third party that designs it and you're installing their equipment. The pros and cons to that is a totally separate conversation. But if you're designing your own things and you're anticipating that you might need to iterate on your design, the smallest viable unit is so important. You can't underestimate the importance of building that minimum viable product, whatever it is, how many racks you want to grow or how many units you're going to grow in, and learn your process with that and then build over time. And then it really helps with some of those things. Like Ryan was saying, if you have 6 container loads of LED lights show up, where are you going to put all that? You're going to have a staging area where that can be transferred. And it's much different to unload one container load, but even that is a lot of lights to process at one time.
Yep.
Yeah. Expansion, having the ability to expand, if that is what's in your business model, is important, but you need to very clearly identify where the big ticket items are that you might need to pay for upfront versus paying for in stages. The electrical upgrades is a perfect example of that. You're not gonna, if you have a facility, you're intending at some point in 4 phases to turn the entire facility on. It might be financially just better for you to buy the transformer that will meet the load of that full built out facility up front versus upgrading it as you go. Some of the panel boxes, the same thing. Why would you keep redoing them or adding more when you could do it in one shot, have that expansion plan ready, but not have to recur that cost? Another one is cranes. Guys, cranes are expensive to rent. If you're going to use a crane to put equipment on the roof, on the side, anywhere, try to do that all in one shot if possible, because they can be thousands of dollars a day. And if you've got 4 phases and you're bringing the cranes out in every phase, that is significant cost that's being added to your project. That if you have to do it that way, then you have to do it that way. But if you can do that up front, maybe like that does save money in the long run.
I think the long lead times too, that's a consideration that, if you plan on expanding, you may want to get that order in so that you have that ready when you're ready to go to that expansion point. You have the equipment already purchased and on its way, because as Ryan indicated, lead times can be stretched out to a year or longer.
Yeah, and something he didn't mean to mention, but when you're considering your facility, are you wanting to be the permanent landlord, or are you going to be looking to do something like renting out the facility later on? Kind of there, at least put some thought into kind of some future use of those buildings, just to make sure that we know how to properly put that infrastructure in. So if you are looking to do something like renting it out, or you are a renter, then there's some different changes that we need to apply.
Yeah, that can impact your whole facility design if you're renting the unit versus buying it, and how you space the supports and things like that.
Yep. Yeah, in these last minutes, do you guys have any closing items that you might want to bring up? There's so many things that you can talk about. I mean, this is just, we're talking about construction here. This is not an easy thing to really fit into one short session. There's multiple different avenues of communication, sewage utility, water utility, gas utility. There's making sure that you're talking with your local water treatment plant to make sure you're not putting chemicals in that water that they're just like, we don't do that here. No. Like, these are things that all need to be kind of thought about, and can't be ignored really, because you don't want them to come around and get you after that building is done.
I would just say it's a team effort from the owner, the team that the owner has put together relative to what they want to grow, to the engineers that they're hiring to put all of this together, to the utilities, to also the local code officials and the local authorities, because they're very much interested in having these facilities brought into their localities, and they get excited about it. And it's important to go and get them on board and get them excited about it, because they're typically exciting projects and something different that most people don't realize that this is happening in their community. And so any way you can embrace those people that can be involved, to get them involved and just make it a great project all the way around.
Yeah, when you're reaching out and engaging in, an architect first, let's say, if that architect says that, they've worked with other engineers and contractors for a project similar to what you're working on, you can sometimes rely on that with some confidence, because that level of communication's already been established. It can be, when I first started as an engineer, what I was told is the hardest thing I'll do as an engineer is just deal with people. And sometimes when you've already worked with some people, you've already worked out the best methods of communication and collaboration between, us and an architect and contractor. So sometimes having those teams presented to you can sometimes be a really big benefit.
I would say there's so many things to say about this industry, but the one thing would be, there is no such thing as a dumb question in this space. Remember, this is a new industry, and if you are not asking as many questions as possible, or bringing in people to ask questions, that's where the pitfalls lie. So do not be afraid to ask any questions, and reach out to people with experience. Reach out to myself. I take calls all the time with people that are just like, can I ask some simple questions? And those simple questions are what's going to drive the knowledge of this industry and make it actually be financially viable and successful. But if we're not asking those questions, you aren't aware of the things that you need to be aware of to be successful. So please ask questions, develop a network, and if someone is telling you, oh, I'll give you a quote or I got it, don't listen to them. Please don't listen to them. If they're not talking about the failures that they've seen and the experience that they have, be very wary.
Yep.
I think what I want to say is just the importance of the theme of this collaboration, how important it is that we, as we enter this next phase of indoor agriculture, that we talk about how we work together to try to build these facilities to make sure that you're set up for everything that you need to grow properly and successfully. And hopefully you've experienced in this. I think of course the engineers know there's more than one type of engineer, and the growers know that there's more than one type of horticulturist with different expertise and things like that. And really that is the point, is that it's not, you don't need one engineer, you need a team of engineers, and you need to be able to talk to them and get advice and all these things. You don't necessarily need them all on your payroll, but you do need to talk to a lot of professionals to get the advice that you need. And the same thing goes with the horticulture and the food safety and all of these other components, that it's so important that you talk to experienced people in the industry and get those outside eyes in on your project so that you can move forward with the best information. You don't have to take everyone's advice, of course, but I would want to know it, right? I want to know what there is to know and what are the challenges in front of me. And then if I see a way past it, then great, that's my decision. But uninformed, just powering through, I hope that this has inspired you to reach out to an engineer or grower, a consultant, and ask for help and fine tune.
Yep, agreed. So yeah, just wanted to thank everybody for joining in today. I thought that was a really fun conversation, and it always gets me going. Makes me want to go out there and do this stuff now. Keep an eye out for any future discussions that we'll be having on CEA, and please feel free to reach out to any of us if you have any other questions. So take care, everybody. Have a nice day.
Thank you.
Right.